All right, so in this section, we're going to cover section 1.6 and 1.7, which deals with absolute value and inequalities. And for this first part, they want us to do two things. One is A, express the graph using interval notation, and B, express each as an inequality involving X. So let me just re-jog your memory what these these terms, what they're asking. So interval notation deals with the parentheses and brackets. So you have the parentheses and then you have the brackets. So the parentheses, that, so if it's an open parentheses like this, that means the endpoints are not included. Okay? The endpoints are not included. And if it's a bracket, then the endpoints are included. So endpoints are included. Okay. So again, um, if you have a parentheses, the endpoints are not included. If you have the brackets, that means the endpoints are included. And that's vital. Those are important information. And then inequality is basically your alligator signs, right? So you have less than equal to, greater than, and greater than equal to. Okay, so that's what they mean by inequality. All right, so the first thing here is they want us to express it in interval notation and then express it as an inequality. So I'm actually going to do it in reverse. I'm actually going to do the inequality first and then do the interval notation. So in this case, we have this graph, okay? And um, we have an open circle here and then a closed circle here, all right? And it's between these particular two numbers. So how would we write the inequality here?
X is greater than -1 and less than or equal to 2. Or
Okay, okay. Let me pause here for a second. Okay, so as I mentioned, we're going to be covering section 1.6 and 1.7, absolute value inequalities. And so we're going to tackle two parts here. One is to express the graph using interval notation, and second, to express each as an equality involving X. So when we have a parentheses, that indicates that the endpoints are not included, and when we have brackets, that indicates that the endpoints are included. Right? So we're actually going to do it backwards. We're going to do the inequality first and then the interval notation. So for the inequality for the first one, um, we want um, X to be in the middle, right? So X will be in the middle, and I know that the lowest number for this particular graph is -1, and the highest number is 2. So and also notice that for -1, it's an open circle. So that means then when we're using the inequality, right, or the alligator signs, then we want the one with the just the less than. Because this one with the less than equal to, that indicates that that endpoint is included. Okay, so if it doesn't have that equal sign on the bottom, okay, less than or equal to, then that means that endpoint is not included. So with the equal sign, it is included. Without the equal sign, it's not included. Okay. All right. So again, this is an open circle. So we're going to have less than. And then for the two, it's a closed circle. That means that endpoint is included. So we'll have less than or equal to. All right. So for the second one, right, we want we want x that is greater than or equal to 1 because we have a filled in circle, right? It's closed. So that's what we want for this one. So we have x is greater than or equal to 1, okay? And then for the bottom one here, it's an open circle, and we want the solutions less than 2, but not including 2. So that would be x is less than 2, okay? Now, notice the arrows here. So for the bottom two, notice that the arrow is going to the right. Right, and this only applies when the variable is on the left. So notice here for the green arrow going to the right, notice that this here, the inequality is also going to the right. All right, so this arrow here is going to the right, this is going to the right. So you need to match that. All right, so wherever the arrow is going. Same thing for this one. This is going to the left, so my inequality here is going to the left. Again, this only applies when the variable is on the left. So, all right, if the variable is on the right, then you have to kind of rewrite it in a way where the variable is on the left. Okay, but again, this only applies when the variable is on the left. Okay, and if you look at down on the first one, we have a closed circle, so that means we have less than or equal to, and we have an open circle, which means we have just a less than inequality sign. Okay, all right. So now let's go ahead and do the interval notation. Like I said, I'm kind of doing it backwards. I did the inequality first, which was part B. Now we're going to do the interval notation, which is part A. Okay, so for this one, we have an open circle on for -1, and we have a closed circle on 2. So that means then for -1, all right, we want parentheses to indicate that endpoint is not included. And then for 2, we want a bracket to indicate that endpoint is included. And you want to write them in order from least to greatest. So note, write in order from least to greatest. Okay. All right. Now for this one here, how would we do that one? Okay, so for the second one here, right, we're going to start at 1 and we're going forever to the right. So we're going to go from 1 to infinity. Okay, and again, we have a closed circle there. So that means that's going to be a bracket. And infinity is always going to be a parentheses. Okay, it's never going to be a closed bracket because it just goes on forever. So we don't know. All right, and then for this one, the last one here, again, the arrow is going forever to the left. So that means we're going to have negative infinity. And then to the right, it goes to 2. But again, 2 is an open circle. So that means that endpoint is not included. So we have a parenthesis. And again, for negative infinity, that's also going to be parentheses. Okay. All right. So again, so what do these mean? All right. So that means that if I were to find out a solution or what number satisfies these inequalities or interval notation, that means that I can pick any number. So for the first one here I'm looking at, I can pick any number between -1 and 2, right? But again, -1 is not a solution, but +2 is a solution, because it says less than or equal to, and any point in between that. Okay, it can be a decimal point, it can be zero point 0.5 or negative zero point 0.5, right? So any point, right, in that number line between -1 and 2 is a solution to this graph. Okay, so any point that I pick in here, let me use a different color, is a solution to that graph. Okay, so again, I can pick any point. In fact, there is an infinite amount of points between -1 and +2. Infinite, because we're talking about decimals, radical numbers, anything. Okay, repeating numbers, all those points in between that is a solution as long as we're in the parameter between -1 and +2. Same thing for this one. Any number that's bigger than or equal to 1 is a solution to this either inequality or interval notation. Okay? So anyway, so you have to think about that. So when you're solving these, does your answer follow suit? If you have this type of graph and then but your inequality here it goes to the left, does that make sense? Again, this is saying less than or equal to 1, but you're saying x is bigger than 1. So again, so these are not the same. So that tells you that um, somehow in the math, the calculation was not done properly. Okay? All right. Okay. So when you solve these inequalities, you want to solve them like as you solve a linear equation. Okay. So you want to isolate the x. So we're going to subtract 2 on both sides here, and the 2's will cancel, leaving us with -3x less than or equal to 3. Then we're going to divide by -3. All right. And so that's going to give us x. Now remember, when you divide by a negative number or multiply by a negative number, the inequality is going to flip. So let me restate that again. When you divide or multiply by a negative number, that inequality is going to flip. So in this case, instead of writing less than or equal to, this is going to be greater than or equal to, and this -1. Okay. So please remember that, right? So that will be our answer in inequality form. If we want to write an interval notation, that means we're going to start at -1 and all numbers that are bigger than or equal to -1. So that's going to be um, positive infinity. And again, don't put the parentheses there. You want a bracket for that one and then the parenthesis for that one. Okay. All right. And then if we were to graph it, I normally tell students to plot 3 points at least. So you always want to put the one that you're focusing on in the middle, -1, and then to the right of that is 0, to the left of that is -2. And then it's going to be a closed circle. Okay. And again, I just follows. If the variable is on the left, I just follow whatever the inequality is saying. It's saying go to the right, so I'm going to go to the right. Okay. So I have my inequality, I have my interval notation, and then I have it in when I graph it, right? So again, your graph should never look like that. This is what I'm saying. Your graph should never look like that. These are not linear equations. Okay, so don't do that, please. They're straight, horizontal. All right, so for the next one here, again, our goal is to get x by itself. And there's a couple ways of doing this. You can distribute the negative if you want, or what you can do is I can divide by a -3. Okay, so divide by a -3. So that gets rid of that. So that gives us 1 minus x. And again, since I divided by a negative, I need to flip that inequality sign from a less than to a greater than. And then 12 divided by -3 is -4. Okay, and then I just, again, I isolate or solve for x. So I'm going to subtract 1 on both sides. The ones here cancel. I have -x is greater than, that's a -1 there, -5, and then I divide both sides by -1. Okay, so again, since I divided by a negative, I need to flip the sign again. So that'll be less than +5 because -5 divided by -1 is going to be a +5. So here's my inequality. Now I need to write it in interval notation. So the highest number I have is 5. That is not included. And then the lowest number that I have is negative infinity, which is also not included. Okay. And if I were to draw that or graph that, I have 5 in the middle, 6 to the right, and 4 to the left. And 5 is an open circle. And again, the arrow indicates, or the inequality indicates the arrow is going to go to the left. So there's my answer there. Okay, so the first thing you want to do here is PEMDAS, right? Please excuse my dear Aunt Sally. So you want to address the parentheses first. So that means then with the parentheses, there is a -4. So you want to distribute that -4 first. So that should have been your first step. Okay. So distribute the -4. So multiply each term by -4. So that's going to give us 8 minus 8, and then two negatives is going to give us a positive. So that's going to give us a positive 4x, less than or equal to -2x. Then I'm going to combine my like terms on the left, or simplify it. So 8 minus 8, right? That's going to give us 0. So these guys are going to cancel, leaving me with 4x is less than or equal to -2x. Then we're going to add 2x to both sides. So the -2x and the positive 2x go away, and we get 0 on the right. And then 4x plus 2x is going to give us 6x, and we divide everything by 6. So x in this case is less than or equal to 0. So if I were to write that in interval notation, I'm going to have negative infinity to 0. Negative infinity is a parenthesis, and 0 is going to be a bracket because it says less than or equal to. And when we graph this, again, I want to graph at least 3 points, 0 in the middle, 1 to the right, and -1 to the left. And my inequality indicates I need to go to the left. So I'll have a closed circle, and my arrow goes to the left. Okay. All right. For this next one here, again, try to solve this like you normally would as a linear equation. So we have a denominator here, so we want to get rid of the denominator, so I want the LCD. So the LCD here, the least common denominator, is going to be 6. So I'm going to multiply everything by 6 to get rid of the denominator. So 6, well, 3 goes into 6 2 times, or you can do 6 divided by 3, which is 2. All right, so this is going to give me 2x here, and then 2 times 6, and then plus, again, these 6's are going to cancel. All right, so that just leaves me with x there. Okay, so we have 2x greater than or equal to 2 times 6 is 12 plus x. All right, then I'm going to subtract x on both sides. So this goes away. We get 2x minus x, which is x, and which is greater than or equal to 12. Right? Then I write this inequality as an interval notation. So it's everything 12 or above. So I have 12 here, and that is included because it says greater than or equal to, and then I want everything above that. So that goes to infinity with parentheses there. And if I were to graph that, I would have 12, 13, 11. So 12 is a closed circle going to the right. Okay, so for these types of problems, what you want to do again is want to isolate x. So you're going to start in the middle, okay, and then work yourself out. So so for the first one here, I again going to start in the middle and work myself out. So I'm going to subtract 2 for each term. And then the 2's here are going to cancel. And then I have 4 minus 2 on the left, which is 2. And I have 2x in the middle. And then I have 8. and then I'm going to divide everything by 2. Okay, so then 2 divided by 2 is 1. These 2's here will cancel, giving me just x, and then 8 divided by 2 is 4. So we get 1, oops, we go from 1 to 4. Okay, like I said, some people like to break this into 2 parts. That's fine, but again, in the end, you have to put them together. I feel like it's a lot more work. Okay, but if that helps you, fine, do it that way. All right, and then in interval notation, we're going to have from 1 to 4, and when we graph this, we're going to have between 1 and 4. So since both are less than equal to, so we're going to have a fill-in circle for both of them, and the line's going to go in between. All right, for this one here, again, we have a denominator, so we want to get rid of the denominator, so we're going to multiply by the LCD. Okay, so the LCD for all these 3 terms is going to be 12. So I'm going to multiply each one by 12 to get rid of the denominator. All right, so 12 divided by 2 is going to give me 6. 12 divided by 3 is going to give me 4. So there'll be 4 times x plus 2. And then 12 divided by 4 is going to give me 3. So, all right, so again, this goes in once, 6 times, once, 4 times, once, 3 times. Okay. All right, and then I'm going to, again, my goal is to isolate the x in the middle. So I'm going to attack that. Okay. So I'm going to distribute the 4 here. That's going to give us 4x plus 8. Okay, and then 3 times 3 is 9. Then I'm going to subtract 8 on all the 3 terms. So I get 6 minus 8, which is negative 2. And then the 8's here will cancel, giving us 4x. And then 9 minus 8 is 1. And the last step here is divide everything by 4. So that gives us negative 1/2 less than equal to x less than 1/4. Okay, so that those 4's will cancel. All right, so we have negative 1/2 to 1/4. So I need to write that in interval notation. So that's going to be a bracket for negative 1/2 and parentheses for the 1/4. And then if I were to graph it, I have negative 1/2 to 1/4. Okay, so 0 is somewhere in there. And we have a closed circle and an open circle for that. All right, so in this part, um, we are going to be dealing with 5 different theorems. Okay, so these are absolute value theorems. So the first theorem is the absolute value of u is equal to a. So that means is if you have this format or this type of problem, you're going to have 2 equations. So you're going to have u is equal to a or u is equal to negative a. When you have the absolute value of u is less than a, then you're going to have one equation. Negative a is less than u, and u is less than a. So, and that's also going to be the same for 3. The only difference is you have the less than equal to instead of just the less than. So that's going to be negative a less than equal to u, less than equal to a. Okay. When you have this theorem here, when this type of problem presents to you, you have the absolute value of u is greater than a. So you're going to have 2 equations. So you're going to have u when u is less than negative a, or when u is greater than a. And the same thing goes for number 5. And in this case, we just need to include that equal sign in the bottom of the inequality. So that's going to be u is less than or equal to negative a, or u is greater than or equal to a. Right. So there are two things you need to be aware of before we start applying the theorem. Number one is note number one is A has to be positive. So A has to be positive. So A is greater than zero. So A is positive. Okay. And note number two, you have to have the absolute value by itself. Uh, have to isolate um, absolute value first before applying the rule or theorem. Okay. All right. So again, A has to be positive, and two, in order to apply or use the theorem, you have to isolate the absolute value first. So that means there's nothing that's being multiplied, added, subtracted to the absolute value. It has to be by itself. Okay, I cannot emphasize that enough. You cannot apply the theorem unless you isolate the absolute value first. So nothing should be with the absolute value that are outside of it. It has to be by itself. Okay? You cannot apply the theorem unless it's by itself. I cannot emphasize that enough. Okay, so as I mentioned, for note number one, in order to apply the theorems, A has to be positive, and two, you have to isolate the absolute value first before applying the rule or theorem. So let's look at the first rule here. It says the absolute value of u is equal to A, uh, and when we see that, we have u equals A or u equals negative A. Why is that? Well, if we go back to when we started learning about absolute value, when you have an absolute value of 3, it's just going to spit out a positive 3. If you have the absolute value of negative 3, that's also going to spit out a positive 3. And if you have the absolute value of negative 5, that's going to spit out a positive 5. So whatever value you put in the absolute value sign, it's going to spit out a positive number. Okay? And that's why it says A has to be positive. Okay? Anyway, so why is that the case? Well, if you were to uh, draw this on the number line, right? How far is 3 from 0? Well, on the left side of 0, it's a distance of 3. So from negative 3 to 0, the distance is 3. And then from 0 to 3, the distance is 3. Okay? So that's another reason why the absolute value is always positive, because it's telling us how far is it from 0 from both sides. Okay? Now, if we were to graph an absolute value, it would be y is equal to absolute value of x. It's going to look something like this. It's a V shape. Why is that? Well, if you were to pick some points in the table, all right, and you plug it in for the absolute value of x. So for example, I picked -4, -2, 0, 2, and 4. If I put a -4 in for the absolute value, it spits out a +4. I put a -2 in the absolute value, gives us 2. And then, of course, all these other ones that are positive are going to be positive as well. So if we were to graph this, this would be a -4, 4. This would be a -2, 2. This would be 0, 0, 2, 2, and then 4, 4. Okay? So -4, 4 is going to be right here. -2, 2 is right here. 0, 0 is right here. 2, 2 is right there. And 4, 4 is right there. Okay? So when I plot those and draw my lines, I get this V shape. And of course, this goes on forever. Okay? So that's why, like another reason why it's positive, because when you put it in the function, it gives you a positive y value. All right, so we have the absolute value of 3x minus 1 equals 2. I look at my theorems chart, and first of all, that 2 is positive a, so I can continue on. Uh, and then it says I have to have two equations, one for negative a and one for positive a. So in this case, I have 3x minus 1 equals negative 2, and then 3x minus 1 equals positive 2. So again, I'm looking at my chart here, and it tells me I'm using theorem 1. From theorem 1, I need to have two equations. Okay. And then once I have those down, then I can solve them. So I'll add 1 to both sides on this side. So that gives me 3x equals negative 1. Then divide, oh shoot. Yeah, negative 1. And divide both sides by 3. Okay, so x gives me negative 1/3. For this one, I do the same thing. I'm going to add 1 on both sides. I get 3x on the negative 1 and positive 1 cancel, giving me equals to 3 on the right side. Then I divide both sides by 3. So x gives me 1. Okay, so that gives me, again, two solutions here, one for the left and one for the right. Okay, so go ahead and try the next one here. All right, so again, the first thing we need to do before we solve this um, or apply the theorem is we need to get the absolute value by itself. Again, I cannot emphasize that enough. So I'm going to put a note here. Note, we need to get absolute value, absolute value um, by itself before applying theorem. Okay. Again, many students start applying the theorem without getting the absolute value first, and that's when they have issues. So I'm writing it down, saying it over and over. We need to get the absolute value by itself. All right, so we have 3 times 1 minus 2z plus 6 equals 9. So the first thing I need to do here is I need to subtract 6 on both sides. So the 6's go away, and we have 3 times 1 minus 2z is equal to 3. Then we're going to divide both sides by 3. Okay, and then that's going to give me 1 minus 2z is equal to 1. Okay, again, I have my absolute value sign here. Okay, all right, so now I look at my theorem. All right, I see my theorem here. A here is 1, it's positive, so that means again I'm using theorem 1, and I will have two separate uh, equations. So let me write that in a different color. So the first one will have 1 minus 2z equals negative 1. And then the second one here, we're going to have 1 minus 2z equals positive 1. Okay, so we have minus 1 here. The ones go away. Minus 2z equals negative 2. Divide both sides by negative 2. And we get z is equal to positive 1. Okay, on this side here, do the same thing. Minus 1. Get rid of that. You get minus 2z equals 0. Divide both sides by negative 2. And then z equals 0. Okay, so those are answers there. We get z equals 0 and z equals 1. All right. All right, so for the first one, again, before I do anything, I need to get the absolute value by itself. So I'm going to subtract um, 2 on both sides here. So that cancels. And we have 4 times 3 minus 5x equals 8. Then we're going to divide both sides by 4. So that gives us 3 minus 5x equals 4. Sorry, equals 2. All right. So now I see my theorem. I'm using theorem A. A is positive, so I can move on. So then I'm going to have 2 equations here. 3 minus 5x equals negative 2. And then 3 minus 5x equals positive 2. Then I solve for each equation. So we're going to have negative 3 minus 3. That cancels on the left. We got minus 5x equals negative 5. Divide both sides by negative 5. X gives us 1. All right, this one, we're going to subtract 3 and 3 on both sides. We got negative 5x equals negative 1. Divide by negative 5. So x gives us 1/5. Okay, so we get 1/5 and 1 as our solutions to the problem. Okay, now let's look at the second one here. We got the absolute value of 2 minus v equals negative 1. Let's say we try to apply the theorem here. So I'm going to use a different color. Okay, so I have 2 minus v equals negative 1 and negative 1, and then 2 minus v equals negative 1. All right, so what's going to happen here? All right, so if I solve this, I get 2 minus v, and negative 1 times negative 1 is a positive 1, so minus 2 gives us negative v equals negative 1. And then I divide by negative 1, and I get v equals 1. On the right side, I do the same thing, minus 2. So that cancels. I get negative v equals negative 3. Divide both sides by negative 1, and we get v equals 3. All right? So if I plug it in, all right? So let's go back on the left here. If I plug this in, am I going to get a 10? So if I put a 1 in here, I'm going to get 3 times minus 5, right? 3 times, sorry. Yeah, so 5 times 1 is 5. So 3 minus 5 is going to give us a negative 2. And the absolute value of negative 2 is 2. So that's going to give me 4 times 2, which is 8. And 8 plus 2 is 10. So that checks out. Okay? And I do the same thing for 1/5, and I get the same thing. When I plug in 1/5 in here, it's going to give me a positive 10. So again, you can always check your answers. That's the beauty of math before you submit it, because you can tell whether you got the problem correct or not. If I do the same thing here, right? If I plug in 1 in for my v, so I have 2 minus 1. So 2 minus 1 is 1. The absolute value of 1 is 1, isn't it? However, it's telling me it's negative 1. Is that true? No. I do the same thing here. If I plug in 3 in for v, I'll be 2 minus 3, which is a negative 1. The absolute value of negative 1 is also 1. However, it's telling me it's negative 1 here. So what's happening? Am I doing this incorrectly? And the answer is no, I'm not doing it incorrectly. I'm doing this just fine. However, remember what I mentioned, in order for us to apply the theorem, A has to be what? Positive. A has to be greater than 0. Has to be positive. Okay? So if A is not positive, then we cannot apply the theorem. The theorem doesn't work. So in this case, here we did all this work, which is great, but again, it's not correct because the solution is no solution. It's not possible. because it's telling us that this is equal to -1, which is not true. So in this case, I didn't have to do any of this work. Okay? I would just write, if I see this, I say, that's not possible. No solution. Not possible. No solution. Because A has to be greater than 0. It has to be positive. All right, so I look at my problem here. I have the absolute value of 3x is less than 15. I look at the theorem and I'm going to be using number 2 theorem. Okay, so that matches my number 2 theorem. Again, I don't have to do anything with the trying to get the absolute value by itself because it's already by itself. So I can just immediately use theorem 2 here. Okay. All right, so that means I'm going to have one equation. On the left side, it's going to be -15, and on the right side, it's going to be +15, and then 3x will be in the middle. So we have less than here, less than here. Then we're just going to solve. So we're going to divide each term by 3, and then that gives us -15 divided by 3 is -5, is less than x, less than 5. Okay? And if I were to draw it, again, this is the graphing part that you'll see. You just um, draw a line, open circle on both ends. Okay, so for the next one, we have, notice that the absolute value is not by itself. So we need to get it by itself. So again, in order to apply the theorem, we have to get the absolute value by itself. So we have to subtract 3 on both sides. That gives us the absolute value of x plus 4 is less than equal to 12. Okay. And then now it's by itself. Now I can apply the theorem. And this one is theorem number 3. So I'm going to have the -12 on one side and +12 on the other side, and then x plus 4 in the middle. And then I put my inequality on each side of x plus 4. And then I solve for x, so I'm going to subtract 4 on all 3 terms. So -12 minus 4 is -16. The 4 and -4 cancels, and then 12 minus 4 is 8. Okay, so our answer here is -16 to 8. Again, if I were to draw this on the number line, I'll have -16 close circle, +8 close circle, and the line going in between. Okay, so as I look at this, we have the absolute value of 2x is greater than 6, so that means um, I'm going to use theorem 4 here to solve this problem, all right, because it's, again, my a here is positive and it's a greater than sign. So I have to have two separate equations here. So I can apply the theorem immediately. So I'm going to have 2x is less than -6, and this says or 2x is greater than 6. Okay, so again, I'm just applying theorem 4 there. Then I just solve. So divided by 2, x gives me -3. And then for this one, divided by 2, x gives us greater than 3. This should be less than -3. All right. So if I were to graph that, I'll have -3 on one side, +3 on the other side, and then my graph will go to the left here, and my graph here will go to the right. Okay, so don't forget to do that. On this one here, again, my A is positive. I don't have to do anything to the absolute value, which is great, so that I can immediately apply the theorem. I'm applying theorem 4 again. Okay, so I'm going to have 2 minus 3x less than equal to -1, or 2 minus 3x is greater than equal to +1. And then we solve. So I'm going to have subtract 2, that gives us -3x less than equal to -3, divide by -3. And then that gives us x. Once we divide it by a negative number, that's going to flip the sign to a positive 1, because negative 3 divided by negative 3 is 1. Then I do the exact same thing here on this side. I get negative 3x is greater than or equal to negative 1. Divide both sides by negative 3. And when I divide by a negative, again, that flips my sign or inequality, and then I get 1/3 there. Okay, so then we just draw this on the number line. So we have 0, 1/3. All right, so 2/3 and then 1. Okay, so 1/3 is right here, and it's a closed circle going to the left. And then 1 is here, and it's also filled in. It's going to go to the right. Okay, so that will be my answer for that one. Okay, questions? Okay, so the first thing again we need to do is get the absolute value by itself. All right, right now it says -2. If it was by itself, we would talk about that. But right now it's not by itself, so let's get it by itself first. Okay, so we're going to add 7 to both sides. Okay, and so that gives us 5 times 1 minus 4x is less than 5. Okay, and then we're going to divide both sides by 5. So that gives us 1 minus 4x, the absolute value, is less than 1. Okay, so we're good so far. We look at our A is positive, so we're good. And let's move on here. So in this case, I'm going to have less than A, so it'll be negative A to positive A. So that's going to be -1 less than 1 minus 4x less than positive 1. And then I'm going to solve for x. So subtract the terms by -1. That gives me -2 minus 4x less than 0. Then divide both sides by -4. Okay, so that gives us 1/2. The 4's cancel, and this one gives us 0. Now, since we divided by a negative number, that means we need to flip the inequality. Okay, so this will be our answer, or you can write it as 0 less than x less than 1/2. Either one, okay, would be our solution. Okay, so this one here, again, we need to get the absolute value by itself before we solve it. All right, so we're going to divide by -3. So that cancels there. We get the absolute value of 2x minus 5. And since I divided by a negative number, this changes the inequality from greater than or equal to less than or equal to. And that gives us 7 on the right. Okay, so again, we will have theorem, in this case, theorem 3. So we're going to have -7 2x minus 5 and positive 7. Okay, so then we're going to add 5's on both sides. Let me delete that there. This will give us -2. This cancels. This gives us positive 12. Divide by 2. So that gives us -1. X less than or equal to 6. Okay, so that will be our answer for this one. All right. So there is a quick and easy way to remember, or kind of a play on words, of when do we use which theorem, okay? So obviously, for this one, right, that's a value, you have to always have two equations. Well, what happens with the inequality though? Well, notice for the inequality, if it's less than, right, it's one big equation. Less than, right, to play on words, less than, so it's one big equation. When it says greater, right, this is a greater than symbol. This is a great, and then I'm just playing on words on here. Greater, I know that's how you spell it, but greater, that means I'm going to have two equations. Okay, so when I see greater or greater than or equal to, that means I have two equations. When it's just a less than, right? Less than, again, this is just a play on words. I know that's not how you spell than, but less than, then you'll have one big equation. Okay, you're connecting them together. All right.